Good evening, team. Midnight math, huh?
Hello.
What's your cat's name, Aaron?
This one is Toby because he's a polydactyl, so he's got a lot of toes.
Polydactyl. Wow.
Yes.
Poly, I like that.
Yeah, right.
That's pretty creative. You put some thought into that.
That's right.
This one, you say, as though there are many more. Is that true?
He has a brother then as well. So his brother is named Jake because there was that movie with Tobey Maguire and Jake Gyllenhaal that were brothers, and the title was Brothers. So
Nice.
many layers.
I like that. Good deal. Well, y'all are on time. So just to make sure that you are firing on all cylinders, and since I'm teaching the class, just to make sure you're informed. So let's see, student view. So this is what you see over here, just to make sure you're dialed. Notes and videos. I went in last Monday night after class. This is what I'm going to do every time. I'm going to post the class notes and post the lecture right behind it. It takes a little bit of time for that to upload, but again, if you just want to rewatch something or miss it, I'm going to do that every single time. So you can score that. Cole's here tonight. Cole.
How's it going?
Good to see you, man.
Yeah, good to see you too.
And Logan, were you here last time, Logan? I think you were. Just trying to see people I didn't see before. I don't think.
Yeah, I wasn't here last time. I was having issues with my internet.
Got it. Okay. I didn't think I recognized you. And I'm not sure if Amelia was here either, but anyway, my name's Doug. Call me Doug. You can fire me off emails or messages through my open math regarding, what you're lost on and so forth. Let's see. Because I have a Zoom link kind of for my office hours, and if you fire me a message off or say, hey, can we spend a few minutes getting ready for this test, or something like that, I can always fire up a little one-on-one Zoom. We could just have a quick discussion about something that's bugging you or whatever. Take me up on that, because that's the one-on-one time. I know it's a little awkward sometimes in a group, but I would encourage you, this isn't a large class, to speak up in class. It's even better, just because other people can, sit in on that discussion too, and maybe learn something from it, or, maybe they didn't think to ask that question. And so particularly kind of after class, because we can just sort of linger and talk about whatever you want to talk about. And given that you're taking a test on Friday, I think I set it up to be available. Where did I say 8? I forgot. Let me look and see, since we're talking about this. There is no test. It's gone. Good news for you. That's right. I made a test file. No wonder I couldn't find it. I put it away. Yeah, 8 o'clock. So you can take it any time from 8 a.m. Through the nighttime. So, and I think I set it up for, I want to say 75 minutes, which I think is too much time, but I think it's really important to be able to check your work and graph and think and so forth. So hopefully you can just kind of chill out. I would say, in the event that either you get stuck on a problem or I made the test too long, so that could happen. I usually give paper tests. So I'm not really used to giving online homework tests. I'd say there's a more of a chance you'll be done way early than late. But if you were, for whatever reason, your fault or my fault, to sort of run out of time, I'd still prefer you continue, just like write on paper and then scan it and send it to me as an email and say, this is what I finished and it took me 30 more minutes or whatever. And, if I feel like, well, that's not fair for you to have, an extra hour than everybody else, I still can give you some points for that, right? Because you showed something. And ultimately, in the real world, time is not really an issue. So as much as possible, I really never want time to be an issue. I always want to give you more than enough time, really, so that you have time to screw up. Like if you screw up and graph it, and you then realize that, and then you have time to go, figure that out and so forth. And then and as far as just test taking strategies, make sure if you see one, you're like, I don't feel good about that one. Well, then skip that for last. Like make sure you get all the stuff done that you feel good about quickly, and then then go back and waste a half hour on one question because you're lost or made a mistake or whatever. Just don't get lost on the first question and sit there for an hour and a half and then like, I'm out of time. Anyway, anything you want to ask me, either question wise about what you've been studying or just about the function of the class, since you're having to have a new teacher in the middle of the class. Apologize for that.
Yeah, I've noticed on the 7.1 homework that I'm having many issues with finding the questions with the two smallest possible solution. I can find the first smallest really easily, but it's finding the second smallest solution that no matter what I do, I cannot figure it.
Yeah, I can't either, so I can't help you. I'm kidding.
All right, cool.
Yeah, let's do that. Let's do that right now. I mean, I made up a couple of questions before class started just to kind of play around with, and I also want to demonstrate to you kind of how to check your work, because you should be really you can graph things and check them, so you want to be doing that. As I said before, personally, I love when students send, if on your Scratch work that you're going to submit, you send me a note that says, I know I got this right because I checked it, or actually I know I got it wrong because I checked it, but I don't know why. Those are good notes to send. Allows me to give you more partial credit, so I encourage you to do that. Okay, so let's do that. Let's dive into that right now. I've got me some graph paper ready. Let's see. Which one should we do first? Let's do this. Let's do this one first. So this is primarily 7.1, which is solving equations, but also kind of a little bit of test review mixed into it. So and this is a question that's in your assignment in, let's see, I forget. I think it's on the review actually, but it's a good test question too. But let's say that you wanted to graph this beauty right here. Y equals 2 times the sine of not x, but 3. And I don't know, let's slide it right 4, and let's slide it up 5. So yesterday, or last time we met Monday, I gave you a graph, or, we talked about a graph, and then we found the amplitude, period, and phase shift so that we could write the equation. And now this is the same question, but just the other direction. So can you look at that armed with these notes? Armed with these notes, and again, why aren't you seeing that? I just switched pages to a different note sheet, but for some reason that's not updating. I don't know why. But I'm looking at your 2-page note sheet that Matt, there we go, that Matt sent to you. And so armed with this, armed with that statement right there, and that, in my opinion, this is a good thing to be open note in the real world, just because you would have access to this in the real world. So to be able to look at that and not have to memorize. I could ask you to memorize this as a teacher, but if I saw you on the street 3 months from now, you wouldn't know it anymore, right? So like, to me, the point is to learn how to think, not to just memorize stuff. So the fact that the number in front is the amplitude, and the B is the number in front of X minus C, and then I have to go 2 pi over it to get the period, and the phase shift or the left and right shift is C and the vertical shift is D, and so forth. Like, steal that off the paper. This should be easy once you get it. So in order to graph something, you're going to have to steal all that stuff. In other words, you need to be able to identify the amplitude of this thing is 2. That's easy. And the vertical shift is 5. Notice I picked the 2 easiest ones first. And then the horizontal shift, which again, your book called the phase shift, is really right 4, right 4. And I could even say for 5, it's up 5, it's plus 5, so it's going to go up 5. So this is a sine wave, except for it's taller than normal because it has an amplitude of 2. It's been moved up 5, it's been moved right 4, and lastly, that 3. That's the only number here that isn't what it is. In other words, 3 is nothing. But you can get the period by taking 2 pi divided by that number. So the period is 2 pi over 3. And so now that I've kind of converted from the equation to these 5 statements, now I can actually proceed to make a graph of this based on this. And in my opinion, like there's 2 levels to graphs. One of them is just kind of a rough sketch. The other one is it's really nice. And if I was forced to make one that was really nice, kind of better than a sketch, I'd probably have to make a rough sketch first and then sort of fix it, because it's kind of hard to do all these things at once. Do you agree with that? And again, I don't have a super good feel for how much you've practiced this, but there is kind of an order to this if you want this to work well. So let me kind of demonstrate what that would look like. So rough graph. Let's see, it said up 5. So normally the center line of a sine graph is running along the x-axis, but we just learned 1, 2, 3, 4, 5 that the new center line is actually right up there. So notice I really did this first. Again, I'd prefer you not memorize that. I'd prefer you just watch it unfold and kind of go, yeah, actually that kind of makes a lot of sense. And then I don't know, you tell me, what's the one that makes the most sense next to you? Maybe there's
amplitude.
Yeah, I think amplitude makes the most sense next, because I know the sine wave is going to bounce back and forth, right? And I'd like to know what it's going to bounce back and forth from. And so since the amplitude is 2, then I can say, okay, cool. There's the, if you will, ceiling, and there's the floor. So that sine wave is going to sort of bounce back and forth between those 2. And then, I don't know, what would you do next?
The only thing left is the period.
Well, you still gotta, and the period would be either, this thing is, really tight like this, or it's really long like that. But the other problem I have is, like, where do I start? Like, where do I start drawing this thing? Notice what I just drew. It's kind of indistinguishable. A sine and a cosine wave have the same basic look to them. But because we're doing a sine wave, what I'm thinking in my mind is that sine waves look like this. In other words, that point right there is kind of the starting point. And since that point went right 4, then I'm thinking to myself, well, the normal sine wave would have been right here. Does that make sense? That's what a sine wave would have done since I moved it up 5, except for that point just moved 4 to the right. So 1, 2, 3, 4. So now it's kind of right there. Does that make sense? So maybe it looks roughly something like that. So I'm getting there. Does that make sense? I mean, I kind of have to do one thing at a time. I have to kind of think about it. And what is I'm sort of left with the period now. What does the period mean? What does it mean?
It's the distance from one point in the sine wave to the same point.
Exactly right. Yeah, and in this case, because right now, the only point I kind of know is that point right there. It's kind of like, well, that's going to be over here again, as long as this distance right here is 2 pi over 3. Does that make sense? That's where it's going to be there again. And so there's all kinds of ways to do this, but ultimately the best graph is get out your graphing calculator or Desmos and just graph the dumb thing, like cheat. In the real world, that's what you would do. You would never have to graph this by hand. The only reason to learn to graph by hand is from what we did last time, which is if you have data like tides or something like that, that kind of created a cyclical behavior like that, or electricity has alternating current. In that case, you have to work backwards and you have to understand how a graph works because you can't cheat. So in terms of a sketch, if I just get my calculator and say, what is 2 pi divided by 3? And I say, oh, that's like 2.09. So 2 pi divided by 3 is approximately 2.09. And this is what I mean by, kind of sketching it. So do you see how I'm like, oh, well, I drew that way too far. That's way too long. So now let's go back and kind of improve that. So what does that mean? Where is that next point really? Well, I guess it would be 4, 5, 6, a hair past 6. So it's kind of like right there. So now I realize, oh, I didn't really kind of aim at the right spot. So I've got to kind of be, if you will, going up. I got to be going up right here and then sort of going up there again. So how do I do any better than that? And my first thought is I'll just kind of go, kind of draw a sketch of it, which I think is fine. That's okay. It's a rough sketch. If you have those dotted lines, the fact that, oh, I missed it on the bottom, well, who cares? A better graph is made from a graphing calculator anyway. So as far as the test's concerned, this could be pretty rough. But if you want it to be really good, if you wanted to slow down and be really good, you understand that it's going to actually have to hit right in the middle between those two. Now, I didn't measure that. I just eyeballed it. And then between those two, exactly in the center, does it make sense? That's where it's going to peak. And then between these two down here, that's where it's going to kind of peak on the bottom. Now I got something to aim at. You see what I'm saying? So I could kind of say, well, cool. Then that means this thing's going to come down like this, come up and hit that point, turn around, come down and hit this point, turn around, go back up, and sort of, arrowheads, etc. How's that feel? Now, in my case, I was erasing it, because I got a pen and so forth that erases that. But if I just had a pencil, I probably would have like an ugly one that I sketched up on top. And then I would kind of like, oh, I figured out how this worked now. And then I'd go draw another one and be a little bit nicer. I don't think that was a big ask to stick these extra points in so that I actually had something to aim at. Again, I don't care if it's a little janky. And of course, I could just continue from there and, draw it as long as I wanted to. But again, if I'm you and I'm just learning this, I would think, well, I could have screwed that up just now, either because I did something accidentally or because I actually don't really understand it. And so I want to check my work. So I'm going to go, just because it's easier for you to see, I'm going to go where I showed you yesterday, and I have this app on my iPad. So I'm going to go to Desmos to graph it. So cheat. Y equals 2, we said, times the sine. X minus 4, close parenthesis, plus 5. Notice it's kind of hard to check. Like, I don't know. I mean, that basically looks right. Or does it? It's like I don't really know. It's like I almost have to compare them sort of side by side. Does that make sense? In order to check and see if it really works. But so that I can write it, and I'll bring it back over into our notes. Do you see any evidence there that we got it right or wrong?
Mine's being kind of weird. I'm trying to figure it out.
There's a little wrench up in the upper right-hand corner for this, and also on your calc. I mentioned this yesterday, but notice radians is highlighted, and that's the way graphs usually look. If you switch that to degrees, then all of a sudden the period, instead of being 360 degrees, or instead of being 6.28 is 360, and which is why it looks different. It's actually still the same graph. It's just you've messed with what one period represents. So in degrees, one period around the circle is 360 degrees. So you get this giant long graph. So that's the default. And that is the default for the real world, as odd as it sounds, and also in all advanced math. So you want to get better at radians. So let's bring this back onto our note page and write on a little bit. So what am I looking for to kind of check my work? Well, I'm looking for, that first point that I found right up here that was 4, 5, right? So I'm looking to see, does that point exist? Oh yeah, look at that, it's right there, cool. And then does it repeat itself 2.09? The period was 2.09. So is it repeating itself from 4 just a little past 6? Oh yeah, look at that. And so, okay, I'm done now. That's right. I didn't screw it up. Looks good. Again, do you understand the logic of what I'm getting at? In the sense that this is kind of a useless skill going this direction. Like, why would you work hard to do this by hand when you got a machine that makes a way better looking graph immediately? And the answer to that is, well, it's not really because of this skill. It's because if you're going the other direction. In other words, if I gave you a red graph like that modeled the pluck of a string on an instrument, and you were trying to tune it, so to speak, or any data that kind of took this shape, does it make sense? You can't cheat going the other direction. You can't cheat trying to find an equation that actually models something. And so if you don't understand how to do this by hand going kind of forwards, then you're certainly not going to understand it going backwards. So although nobody would do this question in the real world, it's the learning that comes from that makes it possible to actually model things, which I think is kind of cool. It's kind of worth something.
So how would you check your work if the equation given to you isn't like a nice one like that? Like, the equations that I'm being given are all like, for example, the one I'm looking at now is 6 sine of 6 times x equals 3. And I can graph that in my calculator. And, I did some math to find the second one, but it says that it's wrong. But when I check on my calculator, like looking for an intersection, I don't know if you can see, it verifies that it's right, but I don't know if I'm doing something wrong and that it's just coincidentally the numbers are adding up on my calculator and on paper, but it's still not what the computer is looking for.
Yeah. And you're saying checking solving an equation, right?
Yes.
Yeah. So using a graph to help check solve an equation. So yeah, let's kind of go that direction now. So let's say, just as a measure of practice, notice that there are places where this graph hits, I don't know, let's say 4. There are lots of places where the y value of this graph is 4. And so, second example, what if I gave you this equation to solve, which is the same equation we just did, except for equal to 4 now? And again, I want you to understand practically what I showed you yesterday, which is nobody's ever going to give you an equation like this and say, can you solve this for me? It's going to happen more like, hey, look, I found a sine equation that actually models the minutes of daylight. And I would like to know, when will there be 4 minutes of daylight? And so then you plug 4 in, and now you say, okay, now I got to solve for X, which is, again, the harder thing to do, right? For Monday, it's way harder to be given Y, an outcome that you're after, and then be asked to find the X that produces it. It'd be much easier if I just told you, hey, X is 7, solve for Y. Well, that's easy. I just type that whole thing in my calculator and it just tells me what Y is. But when we say Y is 4, now we're actually using this for something in the real world when the equation actually models something interesting. And so let's solve this, and then, well, let's go back and check the graph in just a second here.
I'm more wondering, what can I do to make equations that don't fit into the a sine b x
Yeah.
minus c plus d
Yeah.
equation?
Yeah, I get
How do I force an equation that doesn't fit that
Yep.
to fit that equation so that I can draw out the graph?
Yep. I totally get it. We'll do that next.
Okay.
So what I would hope is most of this problem is easy based on your prior algebra skills that you practiced in Math 111, which would be, as I said yesterday, hey, let's get rid of that 5. I get rid of adds and subtracts first. So now I have -1 over there. And if you're doing a test, it's really good to take your time and kind of write everything out. Every step, don't try to do too much in your head. Number one, if you do something dumb, you're less likely to do something dumb if you kind of go slow like this. But number two, if you do make a mistake, then I can see what it was and then go, oh, your mistake was small, and, you know, circle it, and you only lost 1 point instead of the whole thing. So then I would get rid of this. So I'm looking for adds and subtracts first, mission accomplished. Now I'm looking for multiplies and divides next. Hey, look, there's a 2. Let's get rid of the opposite of multiply by 2 is divide by 2. So that's gone. Now I'm looking for exponents. Oh, there isn't any exponents. And then I'm looking for parentheses. And so I've got sine of something ugly. And so this is the only place you need to learn something new. How do I get rid of sine? What's the opposite of sine of something?
Inverse sine?
Yeah. And I'm on a roll with good luck here lately, because the inverse sine of -1/2 should stand out to you as something unusual. What do you know what I mean by that? Ooh, like why is that unusual?
It's one of the ones on our unit circles, the key angles.
That's exactly right. It's one of your unit circle ones. And so this is one you could get exact, you could get without a calculator. Remember, people did this for hundreds of years with no calculator. So they kind of couldn't get this. If that was a 1/3 over there, you're out of luck if you don't have a calculator. And I almost wish it was 1/3, because then I could just hit inverse sine and I have to get it exactly right. In the real world, it's very rare when a fraction works like this. So I don't know why that keeps happening. It's just random luck. But since we're doing it, and since that's the kind of thing that happens in a calculus class, let's go look at this formula sheet of yours. What am I looking for here?
A y value of -1/2.
Wish I could say it clearer than that. Sine is y. We're looking for a y value of -1/2. You should be like, hey, y values are, you know, down here, negative y values. Hey, look, there's one. Hey, look, straight across from that, there's another one. I hope you're not like randomly looking around on the circle like you have no idea where to look. Don't tell anybody if you are. Wouldn't a y value, if this is a y value of -1, wouldn't a half be right there? So then look, I mean, you should kind of almost be able to go right to it, is what I'm saying. And so what I see is, oh, look, you know, the answer to one of them is 11 pi over 6 and the other one is 7 pi over 6. And so I can get these exactly right for whatever it's worth. That's cool. Or not cool, depending on how you look at it. So that means 7 pi over 6 is one of the answers. And this is part of what you were saying, Madeline, about there being 2 answers and you not knowing how to get the other one. The other one was 11 pi over 6. And we'll do some more today. Like in this case, you had a unit circle to look at, but if there wasn't a unit circle, does it make sense that where would I get that second answer? Like if I hit inverse sine and I got an answer, where would the other one come from? Like, well, we won't get lucky all night and keep getting ones that land on the unit circle. So then let's see, I got options. I could divide by 3. I think I'm going to divide by 3. So this one would be 7 pi over 18 equals x minus 4. And then of course I could just add 4 to both sides. And so as I've said before, if nobody makes me, I'm just going to stop right there. You know, I mean, I'm done. All right, I solved for x. And, you know, is there any reason I have to find a common denominator and add those together and stuff? Like, I'm not doing that if nobody makes me. as far as my tests are concerned, I would never want you to do that. Should be capable of it, but so the other one would be the same, divide by 3 and then add 4. So this other one would be 11 pi divided by 18 plus 4. But what I'm going to do to check my work is I'd like to know what those are as decimals. 11 pi divided by 18 plus 4 is approximately 5.92. So I'm going to kind of include that in my answer because I want to go to the graph and kind of see if that's really the case. And if I redo that with 7, delete, I get 5.22. Again, it's a good habit to get into to write an approximately equal to sign, just to tell yourself or anybody else that this isn't perfect, but it's darn close. That bothers me. Why are those two so close? That doesn't seem right. Are they actually that close? Did I make a mistake somewhere? Always thinking. Well, let's let the graph decide that. They seems like they're really far apart on the unit circle, right? And that's like all of a sudden they're really clear, both in the 5s. It just feels like, maybe I made a math mistake. So
I got a different answer for 11 pi divided by 13 plus 4. I got 6.65, but I don't.
that
Maybe I'm
actually
wrong.
sounds more reasonable, although that's an 8, not a 3, although it looked like one. But that's the whole point of graphing something. Like, even if you totally had it written down right, like I have a sticky calculator because I've spilled stuff into it, certain buttons stick. And so I hit 8, but 8 doesn't show up. So, there's all kinds of things that can go wrong that have nothing to do with whether or not you understand this stuff. But let's go back to the graph now. And so, and this is part of the answer to your question, Madeline. If you were given the problem like this from the start and you were just told, hey, go solve that, does it make sense there's no graph there? There's no graph, there's no y. So what you do instead is you come and say, well, hey, let's just temporarily pretend that's a y, and then we'll graph this as an equation. But then where do we go looking on the graph? Well, we go looking for where y is 4. Does that make sense? So I'm actually not concerned with the whole graph. I'm just concerned with where is y 4. And now that I look at the graph, I see, hey, there's one, there's one, there's one, there's one. There's just tons of them, right? So one of my questions is, well, is 5.92 and 5.22, does that look like a couple of them? Now I could go to the graphing calculator and check exactly, but this is close enough. I got a pretty good graph here. And so there's 5. And so 5 would be a little past that. So yeah, doesn't that one look like it could be 5.22? And then there's this one right here is a hair short of 6. So I guess I was right. I guess I didn't push any buttons wrong. 5.92 was another one. So there's actually millions of them, but do you notice, and I don't think we'll go into this, but what if the book or the teacher or whatever wanted all the answers that were kind of between 0 and 2 pi? In other words, just give me one lap. Well, notice there's a bunch more. There's a whole bunch that we didn't even list. So let's see, that one's beyond. And so there's basically 4 more. So there's actually 6 answers to this. Did Matt talk about this? How could you have known there was going to be 6 answers to this? It's really because of that.
He did talk about it at one point, but I don't remember it.
Yeah, it's not the kind of thing that would stick inside your head. But in the end, if there's a 3 there, that's going to take the graph and make the period 3 times shorter than it was before, which is going to triple the number of answers. Normally there's only 2 answers, but this is going to triple the number of answers. So that's why there's going to be 6. We'll wait to another problem to kind of figure out, to like talk about how you would figure those out. I consider that to be a pretty picky sort of a thing. But at least we're able to solve this. Does that make sense? And yeah, let's leave that for now. So it worked. We found it. Cool. So now let's just go solve a problem from scratch. Let's see, which one should we do? Let's do this one. So 7.1 talks about solving equations that are a little weird, a little bit hard sometimes. And so let's try an example that's kind of a little bit harder. What if you're just told to solve this equation? What's extremely not good about this problem as it sits? What is not good? Not at all good.
The sines and the cosines are sitting next to each other.
Yeah, well, it's more like just there are sines and cosines. We can solve equations that just have a sine in them, but you can't solve an equation that has a sine and a cosine, because like to get rid of sine a minute ago, there was only one sine, right? Didn't we go inverse sine and we got rid of sine? Well, what are you going to do here? Inverse sine or inverse cosine? Like you can't solve trig equations, well, unless you cheat on a graphing calculator. You can't solve a trig equation unless there's only one trig equation. So sometimes you got to be really creative about that. And we'll do another problem that's even a hair worse in a minute. This one is really tricky. I'd be impressed with somebody leading a class like this that could actually handle this. There's some pretty creative things you could do to get just one trig function using some of these identities, like these identities that show how sine and cosine are related, or perhaps these identities, or perhaps these. Like for instance, our problem has sines and cosines in it. Does it make sense? Hey, that'd be cool. If I had sine over cosine, then I could just replace it with something else, and then there would only be a tangent. Does that make sense? Like that's what we're going to be able to do in this problem. That takes a lot of creativity. So the amazing and horrifying thing about trig is you can always rewrite it some other way. Like there's a sine in that problem. If you didn't like sine, could you replace it with 1 over cosecant? Yep. Now that'd be a bad idea. It just made it worse, but you could do it. So you're sort of never stuck. Like a trig, you can always change it into something else. Or this identity over here, doesn't that have a sine and a cosine? So they're squared, but couldn't you resolve for sine by first subtracting cosine squared from both sides and then square root both sides? So I could replace sine with the square root of 1 minus cosine squared. That might work because now you have a cosine squared and a cosine. Like that might work. Do you see what I'm saying? So it takes a lot of creativity to be really good at this. For those of you that are taking calculus next, we're going to be doing calculus to equations, and sometimes those equations have trig in them. And if you have a trig equation that looks this big and you can replace it so now it's only this big, then the calculus that you have to do will suddenly become easier. So being able to rewrite a trig expression as something else is a really good skill for people that are trying to get good at math. So I can see two possibilities. Either I get really lucky and I can rewrite that expression as sine over cosine and replace it with tangent, or perhaps I can replace it, as I said, with I can replace sine with the square root of 1 minus cosine squared. But I don't want that one. I don't want square roots and squareds and I don't know. If I can avoid that one, I'd prefer to.
I think I figured it out. I came up with an answer that seems okay.
So tell us what you did, since you put a little thought into it while I was rambling away. What'd you do?
Add 4 cosine x to both sides, divide by cosine x, make sine over cosine is equal to 4. And then that's tangent is equal to 4. Tangent inverse of 4 is equal to x, 1.325.
Everything you just said is good. Do you follow that logic? In other words, you first stared and you really don't know what to do, but because there was 0 on the other side, you're able to divide. Oh my gosh, you have sine over cosine. That's amazing. That was really lucky. Do you notice if for instance, on the other side, there was a 6, all of a sudden that wouldn't have worked, because now you'd have 6 plus 4 cosine. And then when you divide it by cosine, you'd also have a 6 divided by cosine. Like this only worked because that was a 0. So this was canned. This is, I made this up very carefully so that this would work. And so you're right. Now you take the inverse tangent of both sides and you've got x. And I heard your answer, but I didn't write it down, so now I've forgotten it. Inverse tangent of 4 is 1 point. Who cares how you round? 1.32, 1.33. What if you were asked, though, to give all the answers from 0 to 2 pi? Remember, there's always going to be 2. The calculator is only going to give you 1. Again, I would ask you the question that most trig students cannot answer, which is, what is that 4 and what is that 1.33? What are those? I don't think that's obvious. I mean, I'm not sure I could have done this when I took this. I'm asking you to read my mind. I don't even know if you know what I mean, but what are those?
Yeah, one of them is the angle and one of them is the side.
Exactly. One of them
Or is
angle.
the angle in radians, and then 1.33, if converted to a fraction, would be the opposite side over the adjacent side.
Do you agree with Nicholas? He said 4 is the angle, 1.33 is the sides. Again, I would ask you rhetorically, I like to ask this question to students. If I gave you $100, how much would you bet on your answer? You might say, well, I'm going to throw this answer out there, but I'm only going to bet $10 because I'm pretty sure I'm wrong and I'd rather keep the other 90. It's just kind of a good way of you deciding, do you actually know this stuff? Because basically, if you can't say I'm going to bet $100, then that means you don't know this yet, or as well as you could, right? Anybody agree or disagree with Nicholas? It's easier to see right here, actually. Tangent of x equals 4. Could you draw a picture of that? What does that look like? Again, if you try to show this to anybody you know, they're probably going to try to get away from you, right? Could you say to them, you know, it looks hard, but that's not really that hard. If you're taking the tangent of it, then what must it be?
Triangle with a 90-degree triangle.
An angle in a right triangle. X is the angle. Now, it doesn't have to be degrees. It could be radians, which is what it is in this case. But because you're taking the tangent of it, it's an angle. If you're taking the inverse tangent of it, then it's sides in a triangle. And again, I would say that's not obvious in this case. One of the reasons I think Nick answered the way he did is because he said, well, 4 is a whole number, whereas 1.33 is a fraction. So he's thinking 4 is a whole number, 1.33 is a fraction. Frankly, it kind of makes you think that that'd be the case. But looking back up here, x is the angle, 4 is the ratio. And since tangent is opposite over adjacent, then that's where the 4 and the 1 would go. Does that make sense? So that's what this means. If you want to explain to somebody what tangent of x equals 4 means, it's like, it's not that complicated. It's just a right triangle, and it's x is the angle and 4 over 1. So this side, even if it doesn't look like it is a fraction, sometimes you have to make it one. So it's like all it is it just told us what that angle is right there. Now, do you see that my drawing isn't to scale? Let me draw it to scale really quickly. This is why I brought graph paper over here. So if this side was 1, that'd be like, I'll go over 3. Then this side would be up 4, 6. So really x is more like that. What would you estimate that angle to be? And again, I don't know about you, but I can't think in radians. For some reason, my drawing is lagging behind. What does that angle look like in degrees to you?
High 70, low 80.
I agree with that. maybe high 70s, low 80s, something like that. The disappointing thing about radians is you got 1.33. So notice there's no like, oh yeah, that looks right. But on my calculator, if I take 1.33 and you, because 180 degrees is the same as pi radians, if I take that times 180, which you would have done in the previous section, divided by pi, I get 75.96 degrees. I don't know why I'm showing this to you. You believe me, right? Roughly 76 degrees. Well, notice that looks right. Again, do you just push calculator buttons, or do you understand what this is accomplishing? So it's like, yeah, that actually makes reasonable sense. Now, where's the other answer though? Bam, perfect circle. Again, could you throw 1.33 now that we've reminded ourselves it's an angle? Do you understand where that would be on the unit circle? As I said
Somewhere in the
yesterday.
first quadrant.
Say again?
Somewhere in the first quadrant.
Yeah, and more specifically, where? Could you roughly locate it?
About 3/4 of the way up from the Y.
Yeah, good job. What I have memorized is, and I showed you this last time, was pi is 180, so that's 3.14, and half of that, I can do that in my head. What's a half of $3.14? It's $1.50 and then 7 cents. Half of $3 is $1.50, half of 14 cents is 7 cents. So this is $1.57. And then this down here would be 3.14 plus $1.57. I have it memorized, 4.71. So based on that, does it make sense? I know that, as Kaylee said, yeah, it's probably right about there somewhere. Notice that creates a right triangle. And doesn't this side indeed look 4 times taller than that side? It's the same right triangle we drew over here. At least proportionally. So where's the other correct answer? Where's tangent's other answer? Is it over here in the second quadrant? Is it down here in the third quadrant? Is it down, or is it over here in the fourth quadrant? Where's the other correct answer that the calculator will never give me?
It's in the third, isn't it?
Yeah. Can anybody explain why? Or is that something you just memorized? Why would it have to be in the third?
Think about how tangent is. I can't remember the phrasing used. Just it went right through the unit circle instead of like being mirrored on the other side. I just can't remember the phrasing.
Yeah, there's actually I think I know where you're going with this. It's something like students all take calculus or something like that. I don't know, some little phrase. And notice it isn't very helpful to me because I can't remember it. But I don't have to remember it because I can reason this out. Well, you tell me, if I redraw the exact same triangle in the second quadrant, why doesn't that work? If this length is 4 and this length is 1, isn't it also 4 and 1 over here? Except for one of those is negative, isn't it? Which one?
The one on the left in quadrant 2 is negative.
Yeah, it's like x, y. The y is positive, but the x is negative. So tangent in this quadrant would be 4 over -1. It's -4, so it's not that one. What is it if I go down into the third quadrant?
-4 over -1, which becomes a +4 again.
There you go. Like, figure it out. Like, you don't have to memorize this stuff. 2 years from now, you can have forgot all the stuff you memorized, but you can figure it out. In that quadrant, isn't opposite? This is the angle we're talking about. Opposite is -4, adjacent is -1. Hey, look, that's still 4. So it's the third quadrant. So you can memorize that, but you don't have to. Now, how am I going to name that then? What do I call that point? Reason it out. Like, you don't have to have a formula for this. You don't need to look in your book and have some formula about subtracting from 2 pi or adding pi or subtracting pi. I'm too dumb to keep that stuff straight. Just look at the picture. Whoa, seriously? Yes. My wife just brought me something. Check this out. That's the kernel. I got a feeling.
Oopsie!
I got a feeling class is going to be over in 5 minutes.
You better get that before it gets cold.
I know. I'm going to eat it in front of you.
You are mean.
I just had blueberry waffles. I'm good.
Oh, this is so good.
I got a bag of Doritos. I'm good.
Oh, I love Doritos. I got to grow up sometime. I'm way too old to like Doritos. Thank you. Okay. Sounds like a good idea. So this should be obvious where that is. If this is 1.33, isn't that a straight line? So how am I going to get over there? Say that one more time. You broke up.
I said add pi or 180,
Yeah.
depending on what mode you're in.
I'd be willing to bet you whatever chapter this is in the book, there's some formula inside a box that says the other answer for tangent. You just take the other one and add pi. And that's true. But like, I don't need a formula for that. You see what I'm saying? Draw pictures of it. This isn't hard. You can understand it. You can reason it out. You can know it 6 months from now. You don't have to just memorize and forget. I can clearly see that I need to add. So there's the other answer, 4.47. Now, what if I don't trust myself? How could I check that?
Take the tangent of the 4.47.
Yeah, take the tangent of
Plug it in for X.
4.47. Now, again, do this on your calculator. You should not expect it to be 4. Why not?
Because we rounded.
We rounded. But I should be darn close to 4, right? Tangent of 4.47, 4.04. Cool. I don't need somebody to grade this. I don't need my open math to tell me I got this right. Check it myself. Now, so that's good. Does it make sense? Well, would you agree an even better place to check this is clear back here? Because remember, I could have screwed up the algebra to even get to tangent, right? So you might try typing that in really quick. And by the way, if I was short on time, I wouldn't check this one. I'd check this one, because didn't that one come from 1.33, which means if I get 4.47 right, then I must have got 1 point. Now, you know, like, what does that save you? 2 seconds? But a better place to check it would be go back here and type sine of 4.47 minus 4 times the cosine of 4.47. I'm going to do that really quick because it's fun. Minus 4 times the cosine of 4.47. And of course, I'm hoping this is 0. Well, it isn't 0, but it's negative 0.01. I don't know if you can see that. So it's like, yeah, pretty close to 0. Cool. I know I'm right. I don't need somebody to check this stuff. So also to check it, to Madeline's point earlier, this is answering her question now finally. How could you graph this? Again, there's no y here, right? So, and this isn't a normal graph. It's got sine and cosine in it. So we don't really have any idea what this graph's going to look like. But what if you wanted to cheat and solve this by graphing? By the way, that is just one of the most important skills there is. In the real world, I teach engineering, and we oftentimes are solving equations to build a bridge or something, and there actually isn't even an algebraic way to do it. So solving by graphing is better in the practical world, because you know you're not going to screw up and it's just easier. How are you going to solve that by graphing? Well, you have to be able to graph it, right? Which means it's got to have a y and an x. Well, I alluded to this a second ago. What do you need to do?
You
Well,
just set it equal to the y value.
Yeah, just stick y in there instead. However, where on the graph? So we're going to get some crazy sine-ish looking graph, but where are we going to be looking? Where's the answer to this on the graph?
At 1.33 and 4.47.
Yes, but how do we know where that is? Does that make sense? I mean, where on the graph is that? Probably asking you to read my mind. It'll be clear in a second when we graph it, but remember, there was no y value here, right? What did we replace with y?
0.
0. That's where we're looking. Look where y is equal to 0. Where on a graph is y equal to 0? You shouldn't have to memorize this. Think about it. Where are the points on a graph where y is 0?
X.
Yeah,
The x-axis.
it's right here, right? Somewhere there. We're looking for where does this graph cross the x-axis? And to Aaron's point, it's going to cross at 1.33 and 4.47. We already know that because we already checked our work, right? So we don't really need to do this to check it. But keep in mind, the beauty of this is this works even if an equation isn't solvable. So let's go look at that. Because we can, because it's fun. Equals the sine of x minus 4 times the cosine of x. Bam, bam. Do you notice I actually just got that problem right and I didn't do any math? If the teacher said, I need the answer to this, you don't need to show your work, that's what I would do. Or if I was actually building a bridge where it was very important that I don't get it wrong, I'm not going to trust myself. And I'm like the nerdiest math person you can get. Like I've done this for 30 years. I'm likely not going to get it wrong algebraically. But even if I did it algebraically, I need to check my work. Like if you ever do anything this complicated in the real world, it will not be okay for you to get it wrong. Do you understand that? You don't get to just ask your teacher, is it right? You got to check it yourself. So, bam. Correct. To make my point from earlier, if that other side had been a 6, this would not have worked. Or what if this had like a suddenly from nowhere, like plus, wow, here's another reason this is better. I didn't even know this was in here. Desmos has all 6 trig functions. You only have 3 on your calculator. But can you appreciate if I just throw something like that in there, you're not going to be able to algebraically solve it anymore. But can you still solve it? Yep. Bam,
With Desmos, yeah.
bam, 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 bam. Solve. Took me 2 seconds. Like graphing is a really powerful technique. Notice it's got all kinds of answers. Apparently it's got, what is that, 8? It's got 8 answers. You're not surprised by that with trig because trig has a cyclic kind of behavior. But graphing is really powerful. So, I mean, it's something we never teach because us math people always act like, you got to do this stuff algebraically and show your work. And that's true to show that you know math and understand it and so forth. But if your goal is just to solve an equation, graphing is way more powerful. How you doing? How's your brain? Appreciate your screens being on. I always look for smoke coming out of your ears and I know, oh, I got to slow down a little bit. They're in pain.
My brain is in pain.
That means I'm doing my job, so okay. But ask questions, ask dumb questions, ask things that you should already know from algebra before. Why did you ask those things? That's important. So to that end, you cheat before you even start this problem. I want you to cheat and solve this problem. And then we'll go see if we can actually do it algebraically because we're math people and we like stuff like that. So I'm going to use a different, I'm going to use a different letter this time. Doesn't always have to be X. Why does X get to have all the fun? M's a good letter. Can you cheat and solve that using a graph? And by the way, can you see that you'd want to do that? Why is this one also hard? Well, because it's got sines and cosines. And by the way, I'm being nice because I keep picking sine and cosine. If I pick cosecant and cotangent, like this would be even worse, right? But this wants to be solved by graphing. You understand that? So we because I was careful to make this up, we can still solve this algebraically. This looks like the last few problems in your 7.1 assignment that maybe you've already done. It also looks like that sheet that I graded that Matt gave you guys to work on by hand. But replace that 0 with a y. By the way, if there wasn't if there was, say, like a 2 over there or something, it's always nice to have the equation equal to 0. Did you notice that Desmos finds the places where it crosses 0 really nicely for you? So even if that had equaled like 10, I would have subtracted 10 to the other side and made it equal 0, because it's really easy to see when a graph crosses the y-axis. That's just kind of a cool, I'm sorry, the x-axis. So graph this. And what I want to know is, again, you just cheat. And tell me the answers to this just in one revolution. Now, again, you shouldn't have much of a feel for what this graph looks like. It's trig-ish, but it's not going to look like just a nice sine wave. This is really kind of a beautiful looking graph. So scope it out. Works fine on your graphing calculator. Your graphing calculator is way more clunky to find the answers to that. I'm going to do this on the graphing calculator for you just because you're probably not as familiar with Desmos, but Desmos is better. Yeah. Y equals 5 sine of x squared minus 3 cosine of x minus 4. I've taught math for 30 years, as I said, and I actually don't know. Is that okay to type like that? I can't believe I don't know this. It's embarrassing. No chicken for you. Is that squared okay there? Is that squaring the x or is that squaring the sine? I bet you some of you actually know that. I don't, but
I think it's squaring the sine. If you wanted to square the x, you would put it inside the parentheses.
In the parentheses. I think that's true. Now I already know what this graph looks like. And if I wanted to be sure, what would I do? Go back here and insert another parenthesis. Does that make sense? Now I know that's what parentheses are, is just you controlling the order of operations. Notice now I'm saying, hey, I want you to do the sine of x first and then square that later. I actually think it's true you don't need those last parentheses, but it doesn't hurt. So let's see, I'm going to go to mode because I don't know if this calculator is in radians or degrees. It's in radians, hit graph. Is that kind of a cool graph? Are you all excited? Like got some tingles going down your spine? Like, wow, look at that thing, man. If you wanted to nerd out a little bit, you could say, well, I was only interested in 0 to 2 pi, so I could go into the window and set the x minimum to be 0 and the x max to be 2 pi, so that I was only seeing the important part of this. And notice I'm zoomed in enough now that I could actually kind of estimate where those are crossing. So apparently there's 1, 2, 3, 4 answers. So it's got 4 answers. That's interesting. So notice, even if I don't want to do any better than this, I can say, well, one of them looks like 1.4, looks like 1.4, 2.5, 3.9, and 4.9. But you know how to cheat to get the calculator to do this, right? From Math 111. It's very cumbersome on the, this is why I wouldn't use the graphing calculator, because there's 4 of them, and this does justify why this works in the graphing calculator. If you say second calculate, that's what a 0 is. And that's the other reason why you want this to be equal to 0. Otherwise, you don't have this luxury. So instead of just saying, here you go, it says left boundary, right boundary. Well, that's because there's 4. And so it's letting you to say which ones you want. So you could just type this stuff. Like, isn't that first one over there between 1 and 2? So you can say my left bound is 1, enter. My right bound is 2. And as long as you guess anywhere between those, I'm going to say 1.5. Then it'll find it. So I guessed 1.4, and my guess wasn't all that great. It's really 1.33 again. So now I just do that 3 more times and I've got my answer, right? So rounded to...
Mine won't actually sit on y equals 0. Like, I hit that thing and it never actually goes to y equals 0.
Yeah, what does yours say right here? Read that to us, because that's not uncommon. If I understand what you're doing, I think I understand what happened there. Are you saying it doesn't say y equals 0?
Yeah, it says y equals 0.358.
Yeah, keep in mind, and if you take calculus, you'll understand how the calculator does this. We're all in the habit of just accepting magic around us all times. Like, here's this phone that's not connected to anything, and I call, and somehow my voice travels through the air to somebody that lives in Arizona. Like, that should bother you. That's a miracle. Same thing is true here. How does the calculator just magically find this answer? Well, it's thanks to calculus. So there's a calculus formula. So your calculator can't do it. It does it. It approximates it. So it won't always say y equals 0 here. It'll say something close to that. In this case, in my case, it got there. And it actually is affected by how much you zoom in, by the way. I was zoomed in pretty far. So my second one's between 2 and 3. So my lower bound's 2, my upper bound's 3. I'm going to guess 2.2 because I'm lazy. So I'll see if that happens this time. So I got kind of lucky again. So 2.57. Anybody have the other two so we don't have to waste any more time? Anybody know
Yeah.
what you are?
3.72,
3.72.
4.95.
3.95. Awesome. Sweet. And of course, in any other class but this class, like if you're in calculus with me next year, I'm not sure if I'm teaching it next year, but I'm teaching it this year. We just assume stuff like this. So like, if it'd be better to just go cheat and get the right answer. This is the only class where you kind of need to show that you know how to do this algebraically. In engineering, I would almost prefer the students cheat to get the answer, because then they know they got it right. And then, the bridge doesn't fall down. We sort of don't care how people get answers after this class. But here is the class you have to prove it. In other words, I would love on a test for you to say, well, here's the right answers, but I blew it and got something else. I don't know where I went wrong, something like that. But again, what we have here, if we're going to solve this algebraically, is a real problem, because we've got sines and cosines. Well, maybe we'll be able to have a sine divided by cosine and replace it with tangent like we did before. But what's the other option? What other identity allows you to switch out either sine for cosine or cosine for sine? Like, what identity should we be looking at here that allows this to have just cosines or just sines, or perhaps replace them all with tangent? Who knows?
Are you talking about the Pythagorean ones?
I indeed am. It is true that the sine of an angle squared plus the cosine of an angle squared is equal to 1. Therefore, you could do a little algebra and say that sine was 1 minus cosine, right? Which means then I could take this and replace that. Now, why would I want to do that? Why am I doing that? What's so cool about that?
We don't have a sine and a cosine in the same function.
And you'd be able to factor.
Yeah, we don't have a sine and a cosine anymore. We just have cosine. So let's see what that would look like. And again, just go slow. Like let your algebra skills take their place. 5 times not sine, but 1 minus cosine. Everything else stays the same. So the point is that's progress because now I just have only cosines. I don't have 2 trig functions. And so now I have a shot at solving this. Are you leaving? Sweet. See you. So again, go slow, distribute 5 in there, distribute 5 in there. I'm not a real big fan of negative signs, so I'm going to add everything over to the other side so that that's a positive 5 cosine squared and a positive 3 cosine of m. And 5 minus 4 would be 1, but if I add it to the other side, it'd be negative 1. Now, again, you won't see a question like this in your book because they work really hard because people haven't had calculators very long. But you ought to see this as a squared equation and use the quadratic formula. In this case, you don't have a choice. This is not going to factor. This is not a nice book problem. So quadratic formula. And again, you learned that in Math 111. When I teach Math 111, I show students how to program the quadratic formula into their calculator because after Math 111, we just want answers to stuff like this. You already showed you know how to write the dumb thing down and solve it, but you know, most people partially forget that. And then even if you know what you're doing, you can still make a math mistake. But quadratic formula says the answer to this, well, the answer being cosine, is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, right? And let's see, that's 9 plus 20, which is 29. So negative 3 plus or minus the square root of 29 over 10. Notice, oh, darn, can't take the square root of 29. So this would not have been possible to solve by factoring. It's just some decimals. So what I do with this is just go to my quadratic formula program that takes like 10 minutes to type into your calculator, and I stick in 5, 3, negative 1, and it just tells me these 2 decimal answers. Negative 0.3, wrong, looking at the wrong spot. Negative 0.83, let's round it off. Negative point, no, it's not, 838, 839. It's 8385, so I'll call it 839. And the other one is 0.239. But, you know, what did I get? Well, the thing that's being squared here is cosine. Does it make sense? So I'm just not quite done. If it had been just m, then I'd say, great, m is negative 0.83 and negative is 0.23. I'm done. But I have the cosine of theta, or cosine of m, I'm sorry. The cosine of m equals, or approximately equals, negative 0.839. And the cosine of m is approximately 0.239. So I just one more step. I just got to take inverse cosine. Remember, I already know the answer to this. That didn't take that long, but I expect those 4 answers to pop up, right? I already know those are right. The graph's not going to get it wrong. Now, I might get it wrong, but the graph's not going to get this wrong. So second cosine of negative 0.839, I get 2.57. I get m It's time to change colors. M is approximately 2.57. Of course, I'm on the edge of my seat. Did I get it? Yeah. No, I didn't choke. I can't believe it. It's a miracle, you should say. That's what I'm saying. And the other one, inverse cosine of 0.239 is 1.33. Look up at my list. Bam. Got it. So that means I didn't choke. I can't believe it. It's a miracle. But there's two other answers. Where's the other two answers? The calculator is not going to give you these. Well, unless you cheat and graph it, like we just said. Again, this is why graphing is so cool. You got to know your stuff, right? So, already used green. Can't use green again. Which coordinate is cosine? Is it x or is it y?
Cosine is x.
Cosine is x. Let's say you forget this because it's been a few months from now, or the teacher doesn't let you have your notes on the final, or you need it in calculus and it's 6 months later. Watch this, super easy, really quick. To get to this point right here, don't you go over x and you go up y to get to that point right there, right? And this is the angle that's involved, and that's 1 in a unit circle. So SOHCAHTOA, what's the sine of theta? What's the cosine of theta? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Oh, that's right. Sine is y, cosine is x. Like, make this stuff for yourself. Don't mindlessly memorize it when you don't have to. You have to memorize SOHCAHTOA, but you don't have to memorize which one of those is x and which one of those is y. The only thing you have to memorize is SOHCAHTOA. So it's like, oh, that's right. Sine is y, cosine is x. So if the cosine, and again, don't be confused. Notice these two numbers both look random. Which one of those is an angle? And which one of those is the ratio of a couple of sides, or an x coordinate, if you will? You notice, again, that's not so obvious. You got to think about that a little bit. This is the sides of the triangle. So that's the x coordinate. That's x over 1. That's the angle. Because if you take the cosine of it, m, it's an angle. If you take the inverse cosine of it, it's a side. So if x was negative 0.839, wouldn't that be about right there? Negative 1 would be all the way at the end, right? So wouldn't it be about there? So the calculator apparently gave me 2.57 is right there. Again, can you see that that looks about right? If this is 1.57 and that's 3.14, wouldn't you say 2.57 looks reasonable? Where's the other correct answer? Right there. All kinds of ways to figure out what that is. One way would be to say, well, how much am I short by here? How much did I miss that by? Well, isn't that 3.14 minus 2.57? 14 minus 7 is 7. 10 minus 5 is 5. So that's 0.57. That's the size of that right there. So then isn't this also 0.57? So then that one would be 3.14 plus 0.57, which is 3.71. So and 3.71. That's one way to do it. So 3.71, check my work. Yeah. Notice I rounded a little too much, apparently. The better answer is 3.72, but I must have rounded a little too much down below. Fine, who cares? Close enough. Is that easy to you? Can you reason that out? I mean, that was something you should have learned in chapter 5, but I find that students memorize too much, and therefore, even though it's like been a month, it's kind of starting to get fuzzy. Doesn't make a lot of sense to people. So what about this one? We got an x coordinate of 0.239. I'd say that's about right there, wouldn't you? So the fact that it said 1.33, that's the answer the calculator gave me. Yeah, that looks right. That's a little short of 1.57. So I'd say that's about right. The other one's right there. So let's do this a different way. If that's up 1.33, then isn't this one also 1.33 except negative? And if nobody tells you otherwise, you could just call it negative 1.33 and you're done. If some person says, I'd actually like to know it positively, then you can't leave that answer 1.33, negative 1.33. So then, of course, I'm reasoning this stuff out. I'm thinking to myself, if I went all the way around, that'd be 2 pi. But then I have to back up. So I'm subtracting 1.33. So 12 is 9, 5 would be 4.95. And 4.95. Bam. That's what we got. We got them all. We got them algebraically. That feels good. Where are they? I lost them. There they are. Yeah, 4.95. So in this case, I don't need to check them because I already cheated to get the right answers in the first place. But remember, if I didn't cheat to graph them, does it make sense? You could just go back here to the start and stick in, well, again, if you wanted to just check this once, what answer would you stick in of these 4 answers I have boxed down here? I'd pick one of those two. Do you understand why? Because those came from the other ones, right? So if I get 4.95, if I choose that one, if I got that right, then that means for sure I got 1.33, right? If I have a few extra minutes, I just stick them all in there. But just make sure they all equal 0. Like you can know this stuff is right. You should not get this wrong and not know it. I want to remind you, this is the last algebra class you'll ever take. So from now on, people think you just know how to do stuff. So it's okay to like make mistakes, both mistakes that are accidents and also mistakes that are, you know, more important than accidents. Like you actually don't know what you're doing, but it's not okay to not know that you don't know what you're doing. You need to know that you don't know and then raise your hand and say, hey, I forgot this algebra concept. How's your brain now? So as a teacher, I've got to be really careful to make up problems you can actually solve, because they're most trig equations, if you just made up something random, you wouldn't be able to solve it because you have to get it down to one trig equation. So if I switch that out, that sine squared, if I switched it out for say tangent, I don't know, like it might not work. Tangent is sine over cosine. So maybe if I change it into sines and cosines, I don't know, I have to think about that. But just understand that you're being given, somebody's working very hard to make sure you can do it. I can just think of one more that I think maybe we ought to do. Let's do, I don't know, let's do something a little uglier. Last example before Kentucky Fried Chicken. Did you notice how hard I worked on this last problem. What was really nice about those two answers that just happened to pop out of the quadratic formula?
They're both less than 1.
Nice job. You read my mind. They're both less than 1. If they were not less than 1, what would have happened?
There would have been an error in your calculator.
Yeah, it would have been.
Like it wouldn't have been solvable.
Yeah, it would have been solvable. And so I actually spent some time graphing just to make sure it worked. Let me make something up a little less weird. Notice I'm actually squaring the x here. So isn't that fun? Isn't that a fun graph? Again, one of the things that's amazing about graphing calculators, and keep in mind, like Desmos and your graphing calculator have only been around for about 30 years. So you might be the first human beings that have ever seen that graph before. Isn't that a weird thought? Like no human has ever seen that graph before. I don't know why, I just think that's crazy.
It's a weird looking graph.
It's weird looking, it's really cool. What if I said, let's solve that for y equals 7? What's going to happen?
It won't solve because it only goes up to 5.
Yeah, notice the graph lives between 5 and -5, if you will. And so it'll never be 7. Well, if that happened, if you were able to solve this algebraically, which by the way, I really doubt you are, you'd end up with something like cosine of x equals 2.6. Cosine of x can't be over 1, right? So what Nicholas said before is really important. Cosine of x has to be less than 1 or it's not going to work. And so if I said solve that for when y equals 6 and you were able to do it algebraically, the answer would end up being there is no answer, which would be very frustrating right after 3 hours of solving that. The answer is none. But that's kind of an important consideration. So for that reason, I want to make up a problem right now. So I actually prepared the other 3, but this one I didn't prepare. For that reason, I'm going to pick tangent. Well, I'm going to make it a little worse and pick cotangent. Tangent always works. So I don't have to worry about making something up. So I can fake it. So I'm going to say, I don't know, 3 times the cotangent of 2x minus let's see, I don't need that parenthesis, go away. 3 cotangent of 2x minus 7 equals 0. Let's try to solve this algebraically first. But you don't have a cotangent button, so you're not going to be able to go inverse cotangent. We're very happy that there's only one trig function. Does that make sense? Yeah, only one trig function. Awesome. But I'm not going to be able to use the calculator to do it. So what could I switch out? What could I do?
You could do 1 over tangent instead of cotangent.
Yeah, cotangent is 1 over tangent, or tangent is 1 over cotangent. Those are the same statement, right? So I guess this is the one I'm going to sort of need. So then this would be 3 times 1 over the tangent of 2x equals, well, equals 7. I'll go ahead and add 7 to the other side. So what I need to do is get the tangent by itself. That's what you got to do every time. You got to get the tangent by itself. So you just got to get rid of stuff. So hopefully you algebraically see that I could multiply both sides by tangent, divide both sides by 7, and then I'd be here. And so now, great, I'm in good shape. Now remember, what does that 2 do to the graph of any trig function? I'm not very good at tangent, cotangent, cosecant, all those graphs, but what does that 2 do to the graph? What does it make it do? Does it get taller? Does it get wider? Does it move to the right, move to the left, move up, move down? It's the same as for sine and cosine.
It makes it cycle faster, right?
Yeah, remember that number, it's not the period, but it affects the period. And by being 2, it basically scrunches it together. So this is going to have double the number of answers it would have had. It always has 2, but this is going to have 4 answers. Does that make sense? So you can know that ahead of time. And that's, of course, a bummer, right? Yeah, dang. And of course, the easy one is just to say inverse tangent, second tangent of 3 divided by 7. Make sure to close the parentheses and you get 0.405. So I get 2x is approximately 0.405. I obviously rounded that off. And then of course I just say divided by 2. And so I know one answer for sure is x is approximately 0.202. At least if I haven't screwed up. But of course, all the other answers are, a little more nebulous, a little more difficult. I want to show you how to get these just by logic, though, because like I saw some of the work that I graded, and people have kind of a formulaic way to do this, and that is good actually. If you understand it, it's really good. But let me just show you kind of a, I don't know, just a more logical way to do it that will you'll still know 6 months from now, even when you've kind of forgot the book and all that. So I'm on the unit circle. And notice that x is an angle, like clear back from the start of this problem, you were taking the cotangent of it, so it's an angle. Does that make sense? So I'm going to try to locate that. Notice tangent is a little harder to locate on the circle because it's not x or y. It's actually y divided by x, and so it's kind of hard to locate. So I'm going this way, 0.2 radians. Well, again, isn't that 1.57? So I don't know, here-ish, like I'm not exactly sure, but kind of like over there somewhere. You agree with that?
Something that I've noticed is that while sine and cosine are always, in alignment with x and y, and pi over 2 and 2 pi, tangent is almost always along like the diagonals of those. So if you like cut the pizza into more slices, I guess,
yeah,
where it would be around pi over 4.
Yeah, and per what we looked at before, the other answer to this is going to be right over here. But you got to be a little careful with this because the fact that there's a 2x here. So let's see, if this was up 0.202, then I would think that's also down 0.202, and that's past 3.14. So if I kind of add that up myself, 0.202, I get 3.342. So I've gotten like 2 answers. Now, so I'm just going to check my work. I'm going to go back here to check my work. I can't go back to the start because I don't have a cotangent button on my regular calculator. So I just want you to type that in. Type in 3.342. And let's make sure it's 3/7. You see what I'm saying? Because I could have made a mistake here. So tangent of 2 times 3.342. And I'm hoping that's equal to 3/7. 3/7 is not a decimal, I recognize. So 3 divided by 7. And it works. So good, we didn't make a mistake. So, you know, I got the decimal for that 0.4237, and then I checked to see what 3/7 is, and it's 0.42857. So I think it's okay based on rounding. Something's bothering me about that.
Wouldn't you also have to find the ones that are a half period away from the answer?
Yeah, so let's keep going with this. The thing you need to understand is, do you agree that 2 theta is actually the angle we're talking about? It's actually doubled. Or 2x, and so that's 0.405. And so all together, the angle's 0.405, which actually is over here somewhere, 0.405. The problem with these questions is you got to be careful when to divide by 2, because I don't think that green answer we just got is actually right. It's close, and so that's sort of unfortunate.
Yeah, I thought the answer split when you did the tangent inverse. That's where you got the 2 separate potential answers from it, and then you divided by the 2.
Exactly.
So you do this math with the 0.405 and then divide.
So when we did that, I was sort of doing it wrong, and I was just hoping when you checked it on the calculator, be like, wait a second, why is that wrong? But it was, unfortunately, it came out so close that it looked like it was right. So let me show you the correct way to think about this, even though that kind of ruined my illustration. So the 0.405 is correct. We just haven't divided by 2 yet. And so if I go straight across here to the other answer, this is still 0.405. And so if I add 3.14 to that, I get 3.545. So I have those 2 answers right there. And now if I divide them by 2. Now remember though, we're dividing by 2. So let's think about this. Remember, there's more than one way to name the same exact angle. Like what if you wanted to rename this angle over here? Like we can call it 0.405, but what else can we call it? Can't we call it an entire lap? So this seems dumb, right? Because if you added that up, you'd get, what is that, 6.685?
Why would you just add a lap around the circle?
That's what I did.
I think he's just showing that it's the same angle.
Yeah, do you agree that that's 2 ways of saying the same thing?
Yes.
But remember, we're not done yet because we still have to divide by 2. So notice this answer used to be too big because we said, it's like, why would I rename the same exact angle? But if I divide by 2, does it make sense all of a sudden it isn't too big anymore? And so when these, in this case, because there was a 2 here, because of that 2, it doubled the number of answers. So you basically have to double, another way to think about this is you've got to double the number of answers you have here. So I'm gonna have to do the same thing over here, 6.28 plus 3.545. Again, I'm just getting close here, but 9.825, like those are the same exact answer as well. So there's my 4 answers. And now if I just go divide them all by 2, that's the answer we got from the start, sort of the only easy one. But then I've also got to take 6.685 and divide by 2. I'm just going to round it off, 3.343 approximately. That's why a second ago, that answer looked like it worked when it really shouldn't have. Ruined my illustration. And then I've got 3.545 to divide by 2. 3.545 divided by 2 is 1.77. And 9.825 divided by 2, 9.8 divided by 2 is 4.91, approximately 4.91. So there's actually the 4 answers. Those are actually correct. This is hard. People have a hard time with this because when do you get the other answers? You don't get other answers from 0.202. You got to get the other answers from the pre-divided, like this one is the key. You got to take that one and create all 4 of these answers and then wait to divide by 2 till later. Otherwise you end up getting this stuff wrong. If you divide it first and then get all 4 of your other answers from this one, you're going to end up getting it wrong. It's really tricky. Again, maybe I'm not totally sure that I got these right, you know. So again, I might take, say, this one and go back to the start and see if tangent. Actually, not that one, this one. This was actually the answer. Take the tangent of 4.91, which I have to multiply by 2, and just sort of check and see, is that 3/7? I mean, that's what it would take to check it, right? And it actually is.
It is barely closer than the last one you gave that was wrong.
Yeah, that's very frustrating. I had such a good plan there and it didn't work. But I would say in the real world, like in all the kind of advanced stuff I teach, and also the applications I teach of this in engineering, physics, that kind of stuff, this kind of thing doesn't show up very often. Like you're hardly ever using a trig equation that has a number there, if you will. And if you are, then it's applied enough that you're probably going to be cheating and solving it by graphing anyway. So let's go out the door with this. Like that was our original problem, right? So I'm going to cheat and go in and type that into Desmos, where I just noticed, I've never noticed this before, but Desmos actually has a cotangent button. So I'm just going to type not 0 equals all that, but y equals all of that. And I don't have them memorized, but let's just see if it really does have 4 answers and those are them. Y equals was it 3? I have such a bad memory. 3 times the cotangent of 2x or 2 theta minus 7 equals 0. Was that it? What a crazy graph. My brain hurts. It's not letting me kind of zoom in and zoom out. So I'm going to go up here to this wrench and I can actually type in I can adjust the window, if you will, up here, because it's like so many, every time I touch something, it wants to grab. So since I was only interested in from 0 to 2 pi, I'll just say 0 to 7 there. So on a test, it would be good to say, well, I did all this algebra, but here's the right answers. Wouldn't that be cool on a test to say, here's the right answers? And I got the first one right, but I didn't get the other 3 right. You know, what did I do wrong? Now,
Well, with the math I did, I can clearly tell I rounded.
yeah, and notice the other cool thing about this, to Nicholas's point, is like rounding ends up causing kind of some issues here. My answers are not right. These are perfect to 3 decimal places, which is kind of cool. Again, I can't remember the answers we just got, so I hope those are right. But it might be good, since I'm posting the notes, maybe I'll snap a picture of that and throw it in the notes since we're almost done here. All right, I don't think there's anything else we really need to discuss. So we will either answer what questions you have, or we will say we are done. Yeah, I did get those right. Wow, it's a miracle.
I'm confused about where you got the other answers, like from the 0.405.
What about it?
Like, so did you just add like the 3.14 like pi to it and then take that and divide it by 2?
Yeah, the key is clear back in the original problem, collectively that 2x right there was your angle. Like, I don't care if there's a rabbit inside there, that's your angle. Like, whatever's in there is your angle. Even if there was like a 3x minus 7 in there, that entire thing is your angle. Does that make sense? If you're taking the cotangent of it, it's an angle. So since we got down here and we found out that our angle was 0.405, that's why I went back and said, okay, well then let's find 4 different answers for this. Again, knowing that I'm going to divide by 2, that's going to take answers that were outside the range of 0 to 6 pi, but when I divide by 2, they're going to go back into the range of 6 pi. So all 4 of those answers came from 0.405. Does that make sense? And then I waited to divide by 2 till the end.
Yeah, now that you say that, I think I missed like a tiny part of it and I was super confused.
Yeah, and had that been a 3, how would this problem have been different if that had been a 3x?
You just would have waited to divide by 3 until the end.
Yeah, except for I would have even had yet another answer over here and another answer over there. Does that make sense? I would have added another 2 pi to both of those answers. Now I have 6, and then I divide them by 3, and then they'll now be smaller than 6.28. But again, with respect to the test on Friday, like this is pretty far out there in stuff that, you know, you need to know for life and for calculus. Like I don't think I'm going to put a question like this on the test. I want to guarantee that, but I can't remember for sure, so I don't want to guarantee that. But I already made the test. But if I'm the same person that made the test a few days ago, if I'm the same person now that I was 3 days ago, I wouldn't put this on the test.
You just got KFC. You might be feeling kinder than you were a few days ago.
Exactly right. I'm not the same. I'm not the same person. Particularly between now and Friday, because I think your this homework isn't due till tomorrow night, if I remember right. Particularly in this next couple of days, you know, tomorrow basically, because today is over. Send me an email if you have any trouble with the assignment, or if there's anything you want to talk about, just because your test is the majority of your grade. The other thing I'll show you kind of going out the door. Actually, I guess I won't show it to you, but in the grade book, you had that one hand-in homework assignment, but that represented 10% of your grade. I just went into that homework assignment and made it a homework assignment. So 70% of your grade is test, and the other 30% is whatever else you do. because he wasn't giving you take-home quizzes or, you know, very much of that kind of stuff. So that should not be 10. That's too small of an assignment to be 10% of your grade. So I think your grades all went up as a result of that. So you might, again, keep track of that. I mean, I don't make too many mistakes on grades, but, you know, watch that and don't be afraid to question it. But again, with respect to Friday going out the door here, like make sure your scratch work is really organized and clear, because I lean pretty heavily on that, and I obviously need to see evidence that you didn't just poke buttons. And I just showed you how to cheat today on a whole bunch of these questions, and so that's what I'm going to have to assume you did algebraically if all I get is answers, right? So make sure your scratch work is numbered, clean, and, you know, it looks like a human. And it's a little helpful because when I grade your test, I'm going to pull it up on this notepad and I'm going to write all over, and I look like fine tooth comb, not to take points away, quite the opposite, to give you points if you made a mistake someplace. So make sure that's really clear, because I'm going to write all over it and then I'm going to email it back to you individually so that you can look at it. And again, I would invite you to disagree with me. We'll have a conversation about it. If I partial credit, you know, you think, I don't think you should have taken 2 off. I think you should have taken 1 off. I invite you to have that conversation. I don't consider it my job to like hold you down. Quite the opposite. I'm looking for the difference on the test. Will I be able to tell between a conceptual misunderstanding, like you don't understand what you're talking about, versus oops, an accident? You watched me make those. I don't care about those very much. I'm going to take off. If it's worth 6 or 7 points and you get it wrong, it will be worth -1 if your mistake is only a dumb mistake and I can find it. Can I read your writing, and will I be able to find that mistake because it's at least reasonably organized? Don't write me a novel, just show steps like I've been showing to you. I can follow that. It's not. You good? Everybody's good? All right. Stay after if you want to ask questions or get out of here. I got to ask Angel. Trundle sewing machine in the background. When's the last time you Trundle sewing machined yourself some clothes?
I have not yet. That is, I guess, my great grandma's sewing machine. I keep saying I gotta try it once, but it's been years. So
Yeah.
more of a Kenmore fan.
I've got one of those in my house too. That was my grandma's. My
Yeah.
wife actually sewed on it with my grandma, so it's kind of a cool memory. So looks just like that from the distance I'm looking at it from. So
yeah, it's really neat. It's a really neat decoration.
kind of cool. All right.
All right. Good night.
Thank you.